Hi guys, welcome to this set of videos. And what we're going to be doing in this set of videos is we're going to be talking about angle measures and angle bisectors. Now, like we've seen before, this set of videos is going to follow along with the notes having to do with angle measures and angle bisectors, but all of our notes, our sections, our set of videos are going to be driven by an essential question. And our essential question in this one is going to be, let me grab my highlighter, how is measuring an angle similar to and different from measuring a line segment? So if you remember the previous section, the section right before this one, we talked about being able to draw, being able to create and measure a line segment. Now our essential question is, well, how do you do that for an angle? And how would that be similar to and different from a line segment? Now, the essential question is what you should be able, by the time we get through this set of videos, through this set of notes, you should be able to answer that essential question. But to help you answer that essential question, we have a few learning targets or objectives, things along the way that we're going to have to learn together to help us answer that question. So we're going to start off by being able to construct a copy of an angle. This is a construction. How do you construct an angle? All right. Then from there, we're going to take a look at being able to name the parts of angles as well as finding its measure. And finally, we'll talk about angle bisectors. So again, the essential question is really what's going to sort of focus our learning as we go through this set of notes and these videos. It's the question, the overarching question you should be able to answer at the end. To help you answer that question, we have sort of our objectives, the set of tasks, the things we need to learn to help us answer that question. Here we go. Let's just jump right into it. We've already talked about a couple of these. We've already talked about array. So a couple things about array. First of all, in order to write array, give array the name, you need 2 points. You need an endpoint and another point on the line, right? So in this case, we have JK. The endpoint always comes first. J is my endpoint, so it comes first. And to show that it's array, we'll put a line across the top of those letters with an arrow on one side. So the array, JK. All right. Now, when it comes to angles, you're going to need to use rays to create, more than one ray, to create an angle. But before we get to that, we have opposite rays. Really, really easy. These are going to be rays that are extending in opposite directions to form a line. So let's just say that I have the point right here. This is the point A. And then over here I have the point B. And over here I have the point C. I can have the ray AB. So this would be A, B, and it's a ray. Or I could have the ray AC, A, C, and it's also a ray. But when I put these two rays, the ray AB and the ray AC together, end to end, right, I get a straight line, a linear line. The line AB or ACB, they're all collinear. And these are opposite rays. They're going in opposite directions and they form a line. Opposite rays. Very, very easy. Now, and angle. What this lesson is all about. Really sort of the driving focus of this lesson. Angles. So what you're going to do is with an angle, you'll need 2 rays. All right, 2 rays, at least 2 rays. You can't make an angle with just 1 ray. Got to have at least 2 rays. And what we're going to do, right, is it's a geometric figure that is formed by 2 non-collinear rays, meaning they are not opposite rays. Well, I take that back. You can have an angle of 180 degrees, which would be a straight line. For the moment, we're going to say that that is not the case, right? So 2 non-collinear rays with a common endpoint, all right? So here's what I've got. Let me use a couple different colors for you. I have this ray right here. This is the ray BA. And then I have this ray right here. This is the ray BC. What is the common point? The common point is the point B. This is what we call, you can see it right there in the diagram, make a big deal of this. B is, I'll write it bigger so you can see it, B is the vertex. It is the vertex of the angle, the corner of the angle, all right? So B will be the vertex. It's the point the two rays share in common, all right? That ray is an angle less than 90. You could have an angle greater than 90. I have the ray RQ. I have the ray RS. Non-collinear rays where the point R, right, is the vertex. It's the point that they have in common, all right? So in order to create an angle, you need two or more rays, all right? Now, the way that we name angles, all right? So we're taking two rays and we're putting them together to form an angle. Naming an angle, all right? Really, really important, naming an angle. You will use the angle symbol, which I've got right here. So for the first one, this diagram right here, there's, well, essentially there's two ways to write it, and both are perfectly okay. But there is something that you have to keep in mind you must do every time, and it's this. In order to describe an angle, right, you must have 3 points. You must have 3 points. You need 2 points that are on each of the rays, right? So point A is on the first ray, point C is on the second ray. The third point must be the vertex. It has to be the vertex, which in our case is the point that both rays have in common, the point B. Now, when it comes to naming, the vertex must be the middle point. So two perfectly fine ways, perfectly legitimate ways of naming this angle. You could call it the angle ABC. That's fine. A, B is the vertex, so it's the middle point, C, A, B, C. That's the angle ABC. Another way that is just as okay, perfectly legitimate way, would be to go the other direction. This is the angle CBA. B must be the middle point. Because it's the vertex, it must be in the middle. That's how I let you know which point is the vertex. It will be that middle letter. So B must be in the middle. This one over here, right? Again, I need 2 points, a point on each ray. Q is on ray 1, S is on ray 2. The third point has to be the vertex, in this case R, and that point must be in the middle of the name. So angle, to let me know that it's an angle, and then from there, the order doesn't matter except R must be the middle. So I could go QRS, QRS, it's the angle QRS. Or, just as okay, perfectly fine, the angle SRQ. All okay, and that symbol just simply lets you know, or lets me know, that that is an angle. All right, that's how you read the geometry. So let's head on over to the next page, take a look at a few more things here before we get into doing some problems together. All right, so of course, measuring an angle. Now, there are some common angle measures, ones that, we'll see quite a bit, and of course that's going to be 0, 30, 45, 60, 90, 120, 180, 270, and 360 degrees. Of course, with 360 degrees being one complete circle. Also, very important, when measuring angles, the, how do I want to say this? The convention is to measure an angle counterclockwise. So, if you are not told, you will always measure counterclockwise, right? Going in a counterclockwise direction to measure the angle. The only time you wouldn't do that is if you are specifically told to measure in some other direction. But I would have to tell you, right? If I wanted you to measure an angle in a clockwise direction, I would have to tell you that, right? If I don't say measure this angle in a clockwise direction, you will do it counterclockwise. The convention, go counterclockwise unless you are told to do otherwise, all right? So we will always start at what is known as the terminal side, right here, starting at 0 degrees. Pick one of the rays, and you will measure in a counterclockwise direction to your terminal ray, right? Let's say we were measuring to 120 degrees, right? So I would measure from my from my first ray to the other ray, counterclockwise direction, unless you're told to do otherwise. Okay, the protractor postulate, again, remember, postulates are things that don't need to be proven. They're really just kind of common sense. And really all this postulate is saying, if you have a protractor, you can use that protractor to measure any angle, right? Remember the way the protractor works is you would simply set your protractor so that center hash mark is right on the vertex of the angle, and then that protractor just sort of has increments put on it that allow you then to, right, it's got all those little hash marks on it that'll allow you to measure the angle, right? So you'll put the center portion, it'll always be marked by a dash or a little hash, or maybe even someone will have a little indentation. You'll know where that center point is. You put that right on the vertex. Make sure that the base of your protractor lines up with one of the rays. It's got to be right on one of those rays, and then you'll measure to the other ray, the terminal ray. Okay, and again, that would be right at 120 degrees. So on the protractor, right there at that mark, you would say 120 degrees right on your protractor, something like that. Okay, the protractor postulate is just simply saying, hey, we can measure an angle using a protractor, right? As long as you know what ray to start at and you have a terminal ray, use a protractor, you can measure any angle, right? And you don't have to prove that. You got a protractor, you can do it. Just like measuring the length of a line. You got a ruler, you can measure the distance between 2 points, all right? So same thing for a protractor. You don't need to prove it. You can measure an angle. You can find the measure of an angle using a protractor. Now, in the previous, on the previous note set, the previous section, we saw the segment addition postulate. And again, the segment addition postulate simply said this. If I have, if I have a line segment, A, B, and some point, C, right? What happens is if I take AC and CB, right, that has to sum to AB. So AC plus CB. This segment and this segment would be equal to AB. Segment addition postulate. Guys, check it out. We have an angle addition postulate, and it'll make perfect sense here as we go through it. Please notice that I have two angles here, right? I have the smaller angle, angle AOB. I also have the angle BOC. And if I put those two angles together, like I've done here, you get the angle AOC. I am sure that you can figure this out. It's not too terribly tricky, right? That this angle addition postulate simply says this, that the angle AOB, that angle right there, let me do it in green. Actually, you know what? Ooh, I have colors. Let's use them. This guy right here, which is the angle AOB, plus this guy right here, which is BO. Oh, hold up. I'm sorry. I forgot my angle. Is equal to, right? Add those two angles together. What do you get? Yeah. You get that bigger angle, right? It's just like the line segment addition postulate. We have the angle addition postulate where that would be equal to the angle AOC. Really sorry about that. I apologize. So anyway, here it is. Here it is right here. If B is on the interior of AOC. B is on the interior. It's got to be on the interior, just like C had to be on the interior of A and B. Had to be between them. B's got to be between, inside that angle. Then, if that's the case, the measure of angle AOB plus the measure of angle BOC has to be equal to the measure of angle AOC. And again, that's fine. Go ahead and add that measure in there if you want to. Just the lowercase m means measure. In fact, let me write that. In fact, probably from now on what I'll do is I will write that. Now, if you remember back to the segment addition postulate, I gave you the segment addition postulate and then I gave you the converse statement, right? The converse statement, same thing here. This is the angle addition postulate. If B is on the interior, then I can add the smaller angles to get the bigger one. Check this out. The converse statement. Look. The measure of the smaller angle plus the measure of the other smaller angle is equal to the measure of the larger angle if point B is on the interior of AOC. Right? It's saying the exact same thing, just in the reverse order. Segment or angle addition postulate, the converse of the angle addition postulate. Okay, so we did a lot of work with the segment addition postulate. Guys, we're going to do some problems with the angle addition postulate here in just a second. Before we do that, couple of quick angles or terminology that you want to be familiar with. You should already be familiar with, but just in case you're not, again, pause, rewind, stop, go back, watch this as many times as you need to just to get familiar with these terms, all right? An acute angle will always be, in fact, it's written there, but I'll write it right here. Acute angle, the measure will always be less than 90 degrees, right? So an acute angle, less than 90 degrees. A right angle, represented by that little right angle symbol, you just draw a little box in that corner. The measure is equal to 90 degrees. Again, if you've got the notes sitting in front of you, it says that right there. If you don't have the notes in front of you, just writing it a little bit bigger so hopefully you can see it. I know that's kind of small. So acute, a right angle, an obtuse angle is going to be where the measure is greater than 90 degrees, right? It's past 90 degrees. That's going to be obtuse, all right? Straight angle has a measure of 180 degrees, so the measure is equal to 180 degrees. Equal to 180 degrees, that's going to be a straight angle. That's essentially opposite rays, all right? So this is opposite. Opposite rays. Okay, and then you have a reflexive angle. What we call a reflexive angle is going to be an angle that measures past 180 degrees. Past 180 degrees. So when the measure is greater than 180 degrees, you are going to be a reflexive angle. Reflexive angle. And then, of course, finally, a complete angle. If you start at 0 and you go all the way around that circle back to the starting point, you've got a full 360 degrees or a complete angle. So M is equal to 360 degrees. All right, so just a little bit more terminology for you. All right, guys, what we'll do at this point, you now know sort of all the vocabulary that you need to know. You've got all sort of like the little nomenclature and things like that we'll use, notation that we'll use to write and understand the language of the geometry that we're going to be using. Head on over to the next page of the notes. We'll try a few problems together. I'll meet you guys there.